Hello, Year 5. Welcome to this Maths Explainer on understanding hundredths and decimal numbers. We're going to keep this super short, sharp, and just jump right straight into the action. All right, let's dive into this question right away. Which is larger, 1.5 or 1.45? Now, a really common misconception is that having more digits after the decimal point automatically makes a number bigger. So, you might be totally tempted to say 1.45. But is that actually right? To figure this out, we're going to use this absolutely brilliant cheat sheet. Feel free to pause here if you want to look a bit closer, but honestly, don't worry. We're going to unravel the exact rules we need step by step. First things first, what exactly is a hundredth? Well, it's simply the name given to one part of 100 equal parts. Think of it like a giant puzzle. To visualize their size, just remember there are exactly 100 hundredths in one whole, and 10 hundredths neatly make up 1/10. Now, notice how hundredths fit perfectly into our place value chart. They sit right there, directly to the right of the tenths column. And remember, the golden rule of maths here. Moving a digit one column to the right makes it 1/10 the size. So how do we actually write them out? Well, 9 hundredths is written as 0.09. Notice how that 0 acts as a crucial placeholder in the tenths column, making sure the 9 sits perfectly in the hundredth spot. And this brilliantly illustrates just how flexible decimals can be. The number 0.37 can be described simply as 37 hundredths, or we can write it as the fraction 37 over 100, or even split it up into 3/10ths and 7 hundredths. They all literally mean the exact same thing. Let's jump back to our opening question and see how this all builds our answer. To compare decimals, we just look at the digits from left to right. Step 1, look at the ones. They both have a 1, so equal so far. Step 2, look at the tenths. 5/10ths is greater than 4/10ths. And because 5 is bigger than 4 in that tenths column, 1.5 is absolutely larger than 1.45. Mind blown, right? Another totally amazing trick is partitioning, which is really just the act of splitting a value into smaller parts. If we take the number 5.26, we can break it down using standard addition as 5 plus 0.2 plus 0.06. We could use a multiplication equation, or even a flexible two-part model like 5.2 plus 0.06. So many options. So, Year 5s, here's your final challenge to take away from this explainer today. Since you now know exactly why 1.5 is larger than 1.45, how would you partition a brand new number, 1.55, to prove to your teacher that it's the biggest of them all? Grab a pencil, give it a go, and show off those math skills.